All right, everybody. Welcome to our Similarity and Right Triangles worksheet. We did the first two today in class. I don't want to spend too much time on them, but essentially keep in mind that these two are dealing with similar triangles. We know they're similar because all we need to do for triangles is show that there's two sets of congruent angles. So if these two angles are right angles and they share this angle, these two angles have to be the same because they can only equal 180 degrees. So like if this is 40, these are both going to have to be 50. So the get two angles to be congruent, is a similarity theorem, okay? What we're doing here is we're trying to figure out the length of this side BC. And what I know already is that I have this small triangle with sides of 230 and 120, and a big triangle with sides of 315, added those together, and x. So if I just do like 230, small triangle, the big triangle, 315, is going to equal 120 over x. And then all I have to do here is cross multiply. So I can do 37,800 is equal to 230x. I divide up by 230, and I round to the nearest yard, so I went to the nearest whole number, and x should equal 164. All right, in this second triangle down here, the second set of triangles, what I have going on here is angle H, here's angle ODR, and this angle R is actually shared. So what I really want to do is think about this small triangle and try to redraw it so it looks like the big triangle that we had. So now this is angle R. This angle is supposed to be congruent to H, where D is. We have angle O. So really, when I think about the orientation of the triangles, for them to be similar, they're almost drawn so that they look the same. So now that corresponding angles, H and D, right, R and itself, and O and C, are now in the same positions, right? So now if we think about it, we knew that this side was 4, which is this length. This side, OR, is 6, which is really this length in this triangle. And that HO is 4. So this bottom piece we know is 10. And what we're looking for is the length of CD. So after we zoom in, unlock this thing, we're going to call this X, which makes this entire side X plus 4. Okay? So what I'm going to do now is create a proportion. So I have, for example, small side to the bottom side here to the bottom side of the big triangle, and then the right side to the right side. So I can do 10 over 4, if I'm doing big to small, is equal to x plus 4 over 6. And when I cross multiply, 4 times x plus 4 is equal to 60. 4x plus 16 is equal to 60. And then we're going to get 4x is equal to 44 by taking 16 away from both sides. And we divide out to get x is equal to 11. So that would be the answer to this one. Now, if you got 15 in class, remember that means you actually found this length. You called this x. So you would have done a proportion like 10 over 4 is equal to x over 6. And that's this side CR. So you have to actually take 4 away from this length to get this piece. Okay, so just be careful. If you remember, if you got 15 in class, that's what happened. Okay, let's go down to the factoring. Let's start with the easy one. So I just want to factor. I'm not solving. So what are my two sets of parentheses? What are those going to be here? All right. Now in the first shape, remember that we have our standard form, which is ax squared plus bx plus c. And when we see our quadratic, our x squared, we're going to think about drawing our x. Remember the top is AC and the bottom is B. Okay. And this is where we have our three terms. So a, which is the number in front of x squared, is 1. C is negative 24. So AC is negative 24. So my two numbers I'm going to pick have to multiply to negative 24 and add to the number in the middle, which is negative 10. So the numbers I'm looking for are 2 and then negative 12. So I know I'm going to do two parentheses. To get x squared in the front, we have to do x times x. And then I'm going to bring in my plus 2 minus 12, and we're good to go. Okay? Second one over here, we have another quadratic, and this time I can't get rid of the 12 in front, right? There's no GCF here, so we're kind of stuck, okay? Let's not bring that in here. So the first thing I'm going to do is, once again, I'm going to do my x, okay? And I'm going to do my a times c on the top, so 12 times negative 4 is negative 48. And I know that the bottom here, the b, has to add to give you negative 13. So if you think about the numbers that multiply to give you 48, like 1 and 48, 2 and 24, 3 and 16, right? I know I can do negative 16 and 3. And because we have a leading coefficient that's not just 1, like there's a number here now, we have to do the box again, okay? So remember, the first spot in the box is getting the first thing in line here. So this ax squared is going to go first. So this is 12x squared. Our c term, right? This guy right here goes at the back. That's the negative 4. And then what I'm going to do now, okay, is think of my two numbers as both this and this. So this is going to be my negative 16x plus 3x. And that's what goes in these two spots of the box, okay? And now I'm just going to do my GCFs. So 12x and 3x, what do they have in common? They have a 3 and an x. Negative 16 and 4 have a 4 in common. Since it starts off negative from left to right, I put a negative in front of the minus. And then I'm going down, right? So 12x squared and 16x. There's a 4x in common here, and it's positive because I start positive. 3x and 4, they don't have anything in common, so I take out a 1, and it's positive because this first box is positive. So now I know my factors are at the bottom, 4x plus 1, and the right, 3x minus 4. And that's it. I'm done. All right. There's your warm-up with your factoring. Now into our lesson of the day of altitude to the hypotenuse. Actually, I'm going to do another video for this. So after this, we'll pick up where we left off.